So this is a video about learning webGL. I just got started and I googled around. I went to a few websites. The one I liked about learning webGL the best, or just for whatever reason got chosen first, as the one I went far with and gained some understanding of the topic, is this website tutorialspoint.com and their series on webGL. This is the page. So I've gone through the first few tutorials. Let me show you the index. So I'm gonna go through now and try to explain back to you guys, the viewers, what I learned from this website in the recent few days. So maybe if you came across this video and you're learning this stuff too, you'll get through it much quicker. So I'm gonna give to you a textbook with my highlights. So first thing is I guess, basics. Canvas, so I'm gonna skip that. So this is, you have to learn how to use a canvas. So let me show you some sample code with some canvas stuff. You just have to make a canvas. Let me show you the HTML first, actually. Open. So we just got an empty HTML file with just a paragraph, a canvas, and a script. Canvas is 800 by 500, and there's a script name, and here's some scripts. So you just get the canvas. This is just DOM HTML programming, or DOM JavaScript DOM programming. So we get the get element by ID, and then once we have it, now we're working in the HTML5 canvas API, which has a get context method, and we're gonna use, there's two options. One is 2D, to make 2D, use the canvas in 2D and use the 2D API, and here we're gonna use webGL, which is 3D API. And we just check that, all the browsers are supporting it, so this works all over the place. But some really old browsers, or maybe some kind of smaller device that has a limited version of the browser and hardware, if it doesn't have it, then this will catch it. So if you have any problems, just look at the log and it might say no GL support. Okay, so this is copied basically from this website. The same code. I guess Basics has the first website. So here we're learning the coordinates. So the screen is basically X and Y, and then into the screen and out to and towards you is plus and minus Z axis, and out towards you is positive Z, and in away from you and into the screen is negative Z. So that's there right there showing at the top. Negative Z is into the screen, positive Z is out of the screen, and so your screen is aligned with this here, this face here at the front. Okay, so now we can, I guess, there's a graphics pipeline. So the process basically, I didn't really pay attention to this too much, I don't think. I skipped that, and I still don't have that in my mind. But what I do have in my mind is that you're gonna copy to buffer objects, which is just like it's just memory. So it's just like saying var or something in JavaScript. You're opening a buffer, and if it's a single thing, we just say variable. If it's multiple thing and they're the same type, then we say array. And if they're different types, then we say struct. But here in this GL webGL programming, which is GPU programming, we're gonna be it's all about arrays, so they're all same type. So we got GPU has RAM. When you buy GPUs, they have their own RAM, and then your CPU has RAM. So this buffer objects business is all about transferring data from your computer RAM, which is going to be coded and operated on in JavaScript program, and then copying that data to the GPU, which is going to be done in shading language, which is a C type language. And we're gonna see these things: attributes, uniforms, and the transformation matrix is gonna be later. We're just in this today, right now, in this video, I'm just gonna go over attributes, uniforms, and there's also varying, but I don't know how come it didn't get listed. Maybe they get into it later. So this culling, clipping, we're not gonna get into that now. We're not gonna. We don't have to worry about that right now. That'll come after when we get into the matrices. So we're going to go through drawing points, drawing triangles, modes, drawing quad, colors, translation, and then later this stuff. This is how far I got so far, so this stuff will come later. So to the sample program. So there it is. Yeah, see there's GPU and CPU, and GLSL is the GPU, and JavaScript is going to be our JavaScript arrays. So we have a JavaScript array here. We have 1, 2, 3, 4, 5, 6 numbers in there, and points on the XY plane need 2 numbers, an X and a Y. So we have 3 points, 6 values, two points per 2 values, an X and a Y per point. So that makes 6 points. 6 numbers, and for 3 points. So this stuff we can just use it like a boilerplate, you know. Just this is the commands to make something happen. There's 3 of them. So we could probably maybe write something, a wrapper function, and just call it in one function, because we're not going to change stuff here much. The work now when we're going to do stuff is going to be in the vertex code shader. So in this line here, this is the important stuff. The other stuff we can kind of just ignore and just copy paste it every time. So, but we'll just roughly go over it. That's what they do in these tutorial videos. Excuse me. So bind buffer. So now we're making a connection between the vertices that we have in JavaScript, and then this create buffer. Now we just made this made an array, and it of size 6, and filled it with these values. So this one is going to make an array of on the GPU, a rendered size, but we didn't give it values yet. Here we connect the two. We connect the vertices and vertex. So when we give it data, it will automatically go to the buffer on the GPU. And this is how you do it. You specify this type. We don't have to worry about array buffer right now. Maybe in the future we'll try some of the other options, but we're always going to be using this option. And well, actually no, we're going to have 2 options. This option is for the vertices. There's 2 options. Here is the option for vertices, but we'll get into that later. And then when you have indices, which we're also going to get into later, then we change this option. So that's pretty straightforward. We just use it as it is, and just swap out a couple options depending on the changes that we're going to see soon enough. This one, GL static draw, it's always going to be the same in everything we're doing here. So now here, this buffer data, I guess this is when it gets copied. And once it's copied, we can just forget about it. We don't need a handle to it. So we can, the bind GL array is bound to the vertex buffer. Now we bound it to null. So it's not bound to the vertex buffer anymore. So we, this is here line, unbind the buffer. That's what it did. Okay, now we're on the shader. So the vertex is the points. And now the shader is coloring. So this attribute, now this is how here we have vertices, and then in the shader we have coordinates. So these vertices are going to go to our coordinates, and that's why we bound the buffers and copied these data, these copied this data to the GPU, and this is where we're going to use it. But there's more to be done to use this coordinates, make sure this coordinate now is using that data, because this is not, it's not just this. If we had this vertices and we put other vertices, we need to know which ones, so that we need a way for the GPU program to know when we do this coordinates to use these verts that we copied over. So we're gonna see that. So this is like a C program. So you avoid main void, and it's always gonna be that. So forget about it now. Basically, in this thing, we're gonna set GL position, and this program that's gonna be on. This is the program. GPUs are famous for running lots of their great attribute, their selling point, their innovation. The difference between a CPU and a GPU. The GPU is offering to do massive parallel processing. So all this program, we can, when you're making programs, these for loops that might do something 1,000 times or 100,000 or 1,000,000 times, that's a bottleneck in the program. So GPU comes to the rescue by offering massive parallel programming. So instead of doing, when you do programming, there's a stack. When you add a function to the stack, every for loop from I to 1,000 or 1,000,000 is going to be the function added to the stack one after another, and then it's going to add 1,000,000, or there's optimizations there. So you have to, when you're using programming, you have to be familiar with how it's processed, if it's going to be processed one after another, if it's going to cache it and then process it later. You need to know if it's sequential, or for the GPU, these are going to be run separately, not on a single stack. Everyone's going to have their own spot, their own process. This is going to run. If you feed it 1,000, for I equals 0 to 1,000, it's going to do them all not one by one after another, or not one after another, but all at the same time. So that's when you learn about GPUs and what's so great about them for this kind of programming stuff, this is what they mention to you. So here, attribute, you use attribute for the data that you're going to be iterating over. So we have an array of six numbers, and we're going to iterate over those numbers. So that's why you're going to use the keyword attribute for that kind of data. Then you're going to use attribute. Later we're going to see we're going to pass a constant, and then for that we're not going to, it's not array, it's just like, this is, if we said var vert equals 0.5, then that's always going to be 0.5, and we don't have to iterate over the array. So in that case, we're going to use, instead of attribute, we're going to use uniform. So this attribute tells you is the keyword you're going to use, the format specifier for arrays. So each function call, each GPU processor that gets it does massive parallel processing. So this is going to be sent to each to its own processor, and each of them is going to get a different one of these coordinate values. So this is also code that we don't have to worry about, just copy paste, and it's not going to change. It's just commands to take that and compile it like you would compile a C program. The GPU has their own compiler that compiles that. This code, GLSL code they call it, it's named, and then it compiles it, and it's ready to go. So there's a few commands to do it. First you got shader source, compile, and then attach, and then link, and then use. So you just gotta do those things in order. Copy paste. Now this is the part where we get to attaching the we had the we copied the data, but we need to connect this attribute coordinates name that we set. That's stored in memory. Now this needs a pointer to where we copied this. So the way that's done is again just boilerplate code that we're going to copy paste. It's not going to change the same except for this value. So up there we entered coordinates, and up here we're going to enter that same coordinates. Now it's connected. So our buffer is connected just so if you forgot that we bound it up there. Well, we bound it and then bound it to null, so we got to bind it again. And when I wrote the code, I separated it. It's separated here for some reason, but I just moved it down here, and then we don't have it happening twice. But anyways, we bound it here, bound it up there, and then unbound it by binding it to null. We're gonna bind it again now. So now it's that's the memory. So when we now we can do stuff. When we want to point coordinates to it, it's bound. So we get the attribute location in the shader program, and with that we get their pointer, and we enable the pointer, and now it's ready to go. So now this vertex array that we have is bound to this coordinates variable name, attribute vec3 name or vec2 name, and so every time that program is sent to a processor, it's going to send it one of these, and we put here 2. So it's going to send, because we're using X and Y, so it's going to send each program is again each instance of that GLSL vertex code is going to be sent to a different processor with two data each, X and Y each. In this case we have 3 points, so it's going to run 3 processes. I think I explained that maybe too much. And so this is again just like we had compile and attach and link and use. Here we have enable. We gotta enable it after. Just boilerplate. And now with all now we're ready. And then final step, and the money shot. Drawing. Now that we've done everything, we're gonna draw it. So we have 3 points, and this clears the screen. So whatever this is in RGBA, set the color you want it to be cleared, and they're cleared. You do that, and then you draw. So you set your background color right here. That's separated from drawing, and then this is setting the viewport. So that means like your CSS might have 500 by 500, but then here over here you put 1000 by 1000. So that's up to you if you want to do that. If you want to have higher or lower resolution than the actual size, you don't have to match it. And if you have if you're gonna want to, most things you're gonna want to preserve aspect ratio, so you're gonna need that viewport. But we're not gonna get into that until much later. And it's a minor detail. So there, that does the draw. This is the real command, GL draw arrays. This is gonna be the same, but this is where most of the time this is even gonna be the same. But here, this 3 and 0 is telling it what to draw. This is the kind of drawing to do. There's different kinds of ways to draw. You can draw points, lines, and here we're drawing triangles. And within those, there's different kinds of triangle, fan, triangle strip. There's line strip. Yeah, I think line strip also. So we'll see those later. But we're drawing. We have our points size is 2. We have 6 points. So for 2 each point, each point makes 3 points total. So we're saying go from index 0, because at the top is our points. So we're saying going to index 0, which is this one, and then total is 3. So 1, 2, 3. So that's that 0 and 3 there. Okay, now I'll show you pretty much the same code, but all I did was put it in functions. I think I have it open already. So let me close that one. We already looked at that one. So this one is a copy paste of the website. I just put this check in here. That's about it. It's pretty much all the same. Okay, so all I did was in this next one I'm gonna show you. All I did was put it into functions. So the all the attached shader stuff, that shader stuff is in a function. That vert stuff is in a function, and that draw stuff, clear, clear the background screen, clear color, and draw arrays for doing the actual drawing with the triangle type and from 0 to 3. So I put them all in functions, and now we can just call it by calling the function names. So I broke the one program into three parts. So we got our create shaders, verts, and draw frame. So create shaders has our strings and does that all that shader stuff we were talking about, compiling it, attaching it, linking it, and then use program. And verts is where the points are, and the buffers get binded from between the CPU and GPU. And then on the GPU side, we connect the coordinates attribute name that we set in our vertex code, and we set that to, we got that pointer and connected it to our array that's on the vertex. So this is GPU stuff. The data that we copied over, we copied that data over, and then from that data we connect we give our program an address. Usually we just, when we write programs, we just write var my variable, and then we got the address. But here we're doing that separately. We're copying data somewhere, and then we're creating that variable, and then we have to connect that variable. So that's all. It seems like some tricky and complicated stuff is happening, but that's all that's happening. So maybe I can show you in code if you didn't understand what I said. So if you have JavaScript program, you go var my number equals 10. Or if you're in C program, you're gonna go int my number equals 10. So this one is an int, and this one, well, here we're using float 32. So okay, yeah, let's just make it float. In C, you're gonna go float, and then put 0.0 just to be more expressive. Or I think they go like that too. Sometimes they put 10f, maybe 10f. Okay, so we don't have to do it in JavaScript. So now, if you do in two steps, so you go float my num, what you have is a space in memory. This is memory. 8 bits is a char, which is big enough to hold names. So basically, this is just float my number is just a handle to an address. The address is like a byte too, and then that points to a memory. This is actual memory. So addresses, everything is memory. Functions are memory, but now we have to abstract that and think, okay, we're going to use this memory for an address. So this is the addresses, and this is going to save float. We have string literal that's saved, and then when we look up string literal, that's going to give us the address to what's holding 10. Now if so here, so instead of doing it 1, we go like that, and we go my number equals 10. So we did it in 2 steps. Here's 2 steps, and that's what we're doing up here. So we go verts on the CPU equals half 0.5, these numbers here, we put those there. That's basically like number equals 10. And then over here we're doing float my number. That's how we're connecting them. Okay, and then the draw frame, there's going to be stuff we're going to look at here, and we're going to look at we're going to look at this, and we're going to this name here, the data, of course, And so that this here is just doing vertices. Next, let's see what's coming next. Okay, so this probably should take a look at the output. This is number 2. I think I have sample 3. Sample 3 is very much the same. I think I moved the data here. I moved the data, the verts to the out here, and then I fed them through. Before the verts were coming in here, the verts were in here, and I just moved them out. Same with this, I moved it out because we're gonna do work in here, so I might as well just have them by themselves and not indented. Just like for the ease of comfortable typing. And so okay, here I just put put it in a function. So now instead of hard coding data in there, we can just feed it through and then have that same. But the thing is, so when you're doing this, you're thinking, okay, I do generate verts and call verts buffer, and then I can do it again. But I don't think you can. You can't call. This is a one-time draw frame, so you gotta do GL draw erase. That's drawing the whole screen. So you can't. We drew one triangle. So let's look at the result here. Uh, this one here, example 2 triangle. So there it is. So we've got a small triangle, a factor. This is okay. I gotta go through that. So the screen is from 1 to 1. This is 1, and this is 1. This is 1 and 1. Now notice this triangle is wider than higher, so it's stretching it. So that's why you have this viewport. You can make it. You can use the canvas width and height, and then adjust the values and change the aspect ratio. Here the aspect ratio is getting skewed. It's getting elongated along the x. Anyways, I don't think we're gonna see more interesting things. And that's like you're gonna do that on any platform. So okay, so we got over here we got new float 32 array. Every time we're gonna do that. This is a data type that was introduced into JavaScript specifically for webGL, and because JavaScript is loosely typed, it doesn't really matter. Everything is an object, and you don't have to worry about memory. That's the convenience of it. But the GPU doesn't have that convenience. You have to be strict. You have to do strict typing, which is like this, using specific types down to the bit level, the 32 bits we want. Whereas JavaScript, it's up to them. You don't have to ask them, or there's no option to specify usually. So now we have it. We have the option. There's a whole list of them, but we're gonna use this one and one more type, and we don't have to worry about the rest. So you can get into it for fun, but for this purpose of learning WebGL, we're gonna focus on other things. Okay, so that's the first video. That's the first tutorial. Maybe I'll put that code on GPL. It's pretty much on GitHub. It's all the same stuff, just wrapped in functions. Okay, let's see. So you can get it here at this website. Okay, so now we did the drawing a triangle. I should probably go off my notes, 'cause then we'll get exactly what I'm presenting. We'll go in the same order. Okay, so I got 2 sets of notes here. Let's look at the result. Okay, so this one here we're using GL draw points. So here we got one here. And last time we were using 2 verts x, y. This time we're using x, y, z, and we're just setting z to 0. So it's the same, but just for the heck of it, we have the third z's here, but there's zeros. So here, last time we used GL triangles. This time, here's some of the modes: point, line strip, line loop, lines. I think this one's supposed to be fan, triangle strip. Okay, so this is the which tutorial? WebGL context. So I think that was over here. We got sample. The next one comes context. So these are my notes on that. I guess instead of reading through it in the video, I'm just gonna scroll through and show you. Here's all the other types, and I'll post it on my website now, and you guys can, if you want this file. I don't know. I don't imagine you would, but I'll post it somewhere later. Okay, so that's it. It was just so the last time in the GLSL we had vec2, and we fed it verts like this, 2 verts per point. But down here we see 3 verts per point. Even though the third one is set to 0, it's still 3 verts. So this one is XYZ. So instead of vec2, we're going to use vec3. And the final vec is 4 dimensions. The fourth dimension is an actual dimension. I think that's like has to do with the perspective. So clipping, how much is the vanishing point, the angles. But we don't have to worry about it now. But one thing just to note is that before it was 2 x and y, and we had vec2, vec2, and now it's xyz. And z's are all set to 0, so it's effectively the same, but just the formatting is different. Instead of vec2, we're going to have vec3 in there. Okay, so that's the notes on that. I'm going to have to scroll through it. It coincides. I just read this along and made notes as I went. And so what are we doing? We're going to make the context. This is all about the context. And explains that stuff that I was already explaining. So there's those types. We mostly, when we're using verts, we have vertice buffers and indice buffers. We haven't seen indice buffers yet, but we're going to see them soon. Here's one right here. The last one was just verts, but you can also, instead of doing verts, you can use indices. And we'll see how to do that next. So let's look at the next code. And here it is, that vec3 that I mentioned. So when we used, before we had vec2, we just had xy each point. And then we fed the size number 2, but now we're going to use vec3 and feed the size number 3. So let's go to the next one. So that's it, the 3 points. Oh, let me show you the code. Here's the code now. So this one, last time was GL triangles. This one's GL points. And no vertices. I mean, no indices, just verts. So here's the vertices, and at the size of this point, this little square here, that's set GL point size. We set it to 10. That's done in the GLSL, in the shader program. Okay, so that's it. Everything else is the same. Instead of triangles, we drew a line between them and filled the whole thing in, just points. Everything else is the same as the previous one. Yeah, it's all the same. So there's nothing new here. Besides GL points. So that's GL points. Example, 3 points. The next example is parallel lines. Let's see. I think this one is geometry. And when comes the... If you scroll here, go through and explains, and then as examples come, the next example is going to be parallel lines. Oh, this is the page that has all this stuff. I don't need to read this to you. I'm just trying to show you complementary information. This stuff, then if you're interested, and you should be reading this with me. If you're this video is for people who would also be reading this page. Pardon me. So that explains all those steps, the shaders, link, use, attach, link, use, and then that coordinates object, the coordinates data, that's vertex. Actually, how we did that, I showed you already in the last example. and that's the triangle. So GL triangles, vertices 0 to 3, and over here we put, where do we put vertices size? In the previous one, over coordinates variable, we put 3 here. So the 3, I guess this one is for the case 3D, but we put 2. If we look at our code, we didn't put 3, we put 2, because we used 2 data points. We didn't have the 0 yet. Our data is just XY, XY, XY. So over here, we put 2. But here, they're showing you when you have XYZ, then you put 3. So it's 2D and 3D. And then there's draw arrays and draw elements. So this is draw arrays. And here's if you feed the draw arrays more triangles. So each one is going to be a triangle. So what we should do is draw, they drew them 2 side by side. Oh, here it is now, drawing it with indices. Here's 2 indices. Okay, so let's look at the code. Parallel lines code. That's what we're going to do next. So let's find the catch up to parallel lines. Drawing points. Oops. So that's it. The same points, same code. Parallel lines. Draw the triangle. This one we're drawing it using indices. So I'll show that in a minute. So here we're drawing it in 3 parallel lines. We use GL line strip. And just have attribute vec3 coordinates. The shader code is all the same coordinates. We get on the GPU, we connect the GLSL coordinates value to the buffer. Now we draw frame. We have more points, enough for, let's say 1, 2, 3, 4, 5, 6 points. 0. The size is 6. Start at first index 0, and do all 6. So 0 to 5, and let's look at the output. Parallel lines. And there's the output. Now if we change this here to just lines, let's see the change. Now it's like that. So there's different draw modes. See the difference? If we wanted to make connected lines, we could have. If we wanted disconnected lines, that's how you just use lines. GL lines makes disconnected. GL line strips made the zigzag. So we can draw with lines and zigzags now. That's that. After this, after parallel lines, quad. So we're going to put 2 triangles beside each other. So let's open that up and take a look at it. This time we'll open it first, then look at the JavaScript. Oh, what is this? Same quads? Oh no, I opened the same, pardon me, I opened the same file. Parallel quad. There's the quad, now we have a square. And the code for that. I must have it open already. Oh, here it is, quads is open already. So, we have 4 data points. And we use indices this time. So this one, the center is 0, 0. And here is 1. And here's 1. Here's -1. So it's from -1 to 1 in the x and y. So minus a half on the x and positive a half on the y is right here. This point here. And this is negative and negative. Positive and negative and positive, positive. So it goes 0. This one is 1, and this one is 2. This one is 3. So you make an indices array going so 0, 1, 2, 3, right? And we go 3, 2, 1 makes one triangle. 3, 1, 0 makes one triangle. 3, 2, 1 makes one triangle. And then two triangles back to back makes a square like that. Let's see if there's anything else between the two. Oh, when we use draw arrays, it's a different to call. We had GL float, and then we put 0 and the total 0 and 3 for first index is 0 and 3 total to go from 0, 1, 2 for our 3-point triangle. Here we have 4 points, and we're not using verts only, we're using vertices and indices. And the index buffer, it was the same thing as copying the vertex buffer, connecting the from the CPU RAM to the GPU RAM. Copying the indices is the same as copying the vertices. It's just instead of using the option GL array buffer, we use GL dot element array buffer. And then when we use draw elements, then instead of using draw arrays, we use draw elements, and instead of using GL float with draw arrays, with draw elements, we use GL dot unsigned short. And we don't tell it the first index. It assumes we're going to start from the first index. It just needs the length, indices dot length, the total, just as before. So it's the same code, just that verts buffer has been copy pasted into an index buffer, so we have one more function. And then we draw it using triangles as before, except with instead of draw arrays, draw elements. And there it is. The color is in here. It's hard coded, so let's give it. Maybe make this one. Let's make it red. So make it red. Just as adding something in here for the heck of it, but it's all. There's nothing new. Nothing to show here. we saw what we need to see, but for fun, we'll just add some color. Oh, what's going on? Sample webGL app. Buffer. Sample webGL app. Source. Yeah. Okay, maybe we can save it. Saved. That's weird. That's an RGB. Let me see if this one will work. Oh, you know what? I fed it bad data. No, I didn't. 1. I can go 1. Let's change this to 1 too. Let's make sure it's make it green. RG green. Make the clear color green. Let's see if that changes. Yeah, that works. Put it back to. Let's make it 5. It's too green. Make that darker green. Now let me try again. The color of this is each triangle. There's 2 triangles, so this just colors it twice. Okay, we'll change this one to 0. And try this one. 9. So this one's gonna be green again. No, let's change this one to 1. And change this one to 9. Maybe it can't go all the way to 1. No, no difference. So I don't know what's happening. Why isn't that changing color? Let's change this one. So maybe it is changing color, but we can't see it. Because that's so low. that's, I guess, the opacity. Then how come it's white underneath? Shouldn't it be green underneath? That's weird. I guess it isn't. It's white. Oh, maybe it's the CSS background. Make it blue. The page is blue, and then this came out purple now. Did I change it purple? Let's change this back. I must have changed it. The background's not affecting the color. Oh, it is. The background's affecting the color. Weird. So it's a cutout. That is weird. So there's something weird. I just noticed that right now here while we're recording the video. It's like a cutout or something. Let's try to make it black and white, at least. So, opacity 9. It should be green underneath. The clear color is green, so this should be green. Let's make it white. Start there. That's not white. Oh, that's purple. That's red and blue mixed together makes purple. Okay. Now let's make this half opacity. Alpha. Let's put alpha on half, and we should expect a little green to come through. Nothing's coming through. Make it 1. Very little opacity. Okay, so colors. Something weird's going on with color, or make them all 0.9 maybe. Then we'll be able to see some of the background. Whoops. 9. No, none of the background's coming through. Let me start changing background colors when it's white. Let's put it now. Make the background purple. Purple background. Let's make the purple background red. It is affecting. The background comes through. And when you cut this, I guess it deletes it first. The clear color gets applied. Now if you make a triangle, we have 2 triangles. So those triangles, this area of the frame buffer, this is a frame. All this data is held in a frame. And the way the pipeline, there's a pipeline happening. Things are happening before other things. Like if you multiply something and then add, it's not the same as adding and multiplying. So there's a pipeline that keeps things in order. And as you can see, we cleared the color to green, and then we added these 2 triangles to make a square, and the background behind the green is coming through. So this cut it right out. The webGL box here, when you draw on it, you're drawing from a blank slate. You don't have to worry about, don't think that the green that you cleared the screen is behind it. That buffer has gone to 0. And you're drawing fresh. So that's why the HTML behind it is coming through, not the clear screen color. Alright. That was probably not important for this lesson, but we just noticed it. So it is something interesting. Pardon me. Okay, so We did. What's next after that? Float number. That's the quad. Now we add some color. Let's open that up. That's the color. So it's the same box, but this time we're gonna feed color data. So we'll see the how to add colors. So in the last video we saw that we added the data points, the vertices, using the coordinates, variable name, attribute vec3 or vec2 coordinates in the GLSL in the vert code. So here it is, attribute vec coordinates. Now for color, the way the pipeline works is when we pass data from these buffers, the vertex buffer we made and the index buffer for indices. And now we're going to have a color buffer for colors. So the color is going first to the vertex code. You might think, why don't we give it to directly to the frag code? Why do we have to go straight? Why do we have to go through? Because of the pipeline. So on these are going on, I guess, one CPU, not CPU, but one PU, one processing unit. The graphics card has tons of processing units, but it only does limited set of code. It doesn't do everything that you can do in the main function of your C code. But on the GPU in this GLSL, so we have some commands available. This one goes on the stack first, so you can say, in a manner of speaking, maybe it is the same as how the CPU programming stack works. But anyways, this goes first, and then this happens. So the data is going to go here, and if we want this to get data, we have to pass it. So here, we use the coordinates here, and we fill geo position, but we also have to pass the color. So we got to get the color, and then we create a varying vector. So that means it's going to go to the next function and the next shader. That's when we're going to use varying, and then we just this color of the attribute vec3 color, we feed it to varying vec3 v color that we named it. So we do nothing with it here. We just pass it along. Comes in, goes out, comes in, input, output, and then the actual operation. They're connected. Data goes. Now we're in the frag shader. Here we're just sending precision. We don't have to worry about it. Just put it there. And now this one we have to worry about, since we're sending this color data from the vertex shader. In the fragment shader, we need a variable ready to accept it. We need a memory address of where that data is going to go. And here it is. So we made it here, and we got the data, and then here we put that same name. This v color is here. This v color is here. So when it says v color there, it's going to have the data that we put there in this function. So we got the colors. Now we see how we pass the data is the same way as we pass the data for the vertex. So and the indices. So there we did create buffer, bind buffer, buffer data. That's when we actually copy it. And then for the actual variable names, we need those references to point to the data. So here we get the attribute location. So this is some low-level GPU GLSL stuff happening that's accessing memory addresses and stuff like that. That's abstracted away from us, fortunately, with just this single command, and then this another command that does the actual connection and sets up the size. Here it's 3 because we have down here we're not using XY, we're using XYZ. So instead of 2 we have 3. We just have 0, so it's pretty much the same thing. So if you did want to supply, when we get it right now, we're just it's 3D, but we're just doing 2D and we're skipping all the 3D. But if you want to start adding 3D data, here it is. You can do it here. Just feed a 3 now, and then in the GLSL code, the vec2 becomes vec3, and then in the setting the geoposition code, instead of chords, comma 0 0 comma 1 0, the 0 0 is already there. So we just have one more after one more number input. Okay, so we got the colors going, and now there's the colors array. So first one, this is RGB, so 0 on the red, 0 on the green, 1 on the B, so that's blue, and there's the blue. So that's index 0. Index 1 is red, 0, 1. Index 2 is green, RGB, middle one is 1, green. So that's RGB, where's the green? So 0, 1, 2. Now the next one is, oh no, it goes 3, 2, 1. 3, 2, 1, so 3. First one is 0, 1, 0. Oh no, 0, 1, 2. The last one is purple. So 3 is purple. This one is number 3. And then number 2 is 0, 1, 2. 2 is green. So it goes 3, 2, and then probably this one is 1. So 1 is red. Yeah, so there's 3, 2, 1 right there. 3, 2, 1. That's our one triangle. And then the other one is 3, 1, 0. So 3, 1, 0. 3, which is purple. 3, and then 1, which is red. So 3, 1, and then 0, which is green. 3, 1, 0. No, 3, 0 is blue. So 3, 1, 0 to blue. And then here, when we use vertex attribute pointer, we use 3. Here we use 3 because our data is XYZ, our color is RGB. So the 3 dimensions to our color, 3 dimensions to our vertices. Yep, that's number. I think that's it. Translation. Now translation is, now we're gonna use the uniform. Whoopsie. I didn't mean to do that. Translation. Let me open the HTML. Okay, so it's just a triangle there. Translation. Here now you see in this code, when we're going to use translation, we have a uniform. So the verts are 0, 1, 2. We have 3 verts. The verts are being called each for this. Whenever this function gets called, this coordinates value, which is an attribute type, attribute means it's going to iterate over this array. So every time each each processor that executes this function is going to execute. In this case, there's 3 verts. It's going to execute on 3 processors, and each of them is going to get the 1 vert. It's going to get 3 float 32 types. It's going to get 3 floats of size 32-bit. 3 32-bit floats. Each of them is going to get this code is going to be run on, for 3 verts, it's going to be run on 3 processors on the GPU, and each of those processors is going to get one of the X, Y, and Z in vertices. Now, translation, on the other hand, is just the same number every time. So here's the code for translation, and we're just feeding it the same number. So translation is like a constant number. So every function, every process that's going to process these verts is going to process that same translation value. So this doesn't need to be saved in memory in an array, and each processor that's going to process this function doesn't need a different address on the array. They're all going to get the same address. They're all going to use that same value. So that's the uniform type. So last one, we passed the color from, first we started with attribute that iterates over the array. Then we saw the varying type for colors that are going to be passed from the vertex shader to the fragment shader. And now we have uniform for something that is going to be the same for every time, every process, every function call that executes this function they're all gonna get that same number. It doesn't change. So that's uniform. And so in this execution, we have point 1 and point 1. So we look at the verts, and they're point 1 and minus point 1, point 1. We saw this before, so it should be right in the middle. But then we used coordinates plus translation. So we have a translation here, and the translation we set to, and notice coordinates is actually vec4. So let's see our oh, so this data is working, but it shouldn't be working because we have attribute 4, but our actual data is 3. So this works, and let me reload. Maybe I'm looking at the wrong file. Sample web app, buffer, sample 3. See, it's not supposed to work actually, because yeah, number 3, and our buffer here, sample web, okay, and here, okay, here we got 1, 2, 3, 4. So uniform vec4 is correct. Translation is getting 4, but here we have vec4, but and our vertices is vec3. Let's see in here, and here we put 3, but over there we have 4. So I think what we gotta do is change this to 4. So it worked miraculously, I guess. No, not miraculously, but I guess if you give coordinates, I don't know, this shouldn't work. I guess it just, if you add a 3D thing to a 4D thing, you get a 4D thing, and it just fills in zeros for the one that has it missing. So it ended up working. But I'm going to change it to 4, and it should be exactly the same thing. So that's x, y, z, and here's the fourth one here. That one's fine. Oh wait, no, hold on. This one's coordinates. Now coordinates I changed to 4. This one was the uniform. So these two we gotta separate a bit more. Make sure these two are separate. So this is when you're working on this example. This is the few lines of code that you're gonna concentrate on. So 1, 2, 3, 4 going in. This one's correct. Now I changed this one to 4. Now the data's gotta change. So we gotta put right here. Copy this. Copy. Paste it right here. Now they're all 4. Each we have 4 points, 4 data points. So I think this is the W. The fourth one would be W, and we'll put 0 for now. But I think we want it to be 1, or maybe 0 is. We don't know about that yet. About how we'll color the fourth one is the opacity RGBA, and then for location in 3D you have X, Y, Z, and then W for perspective. So I think 0 maybe makes it. We'll find out what's the difference. I'll try 0, 0 0.5, and 1. Okay, so now I'm feeding 4. Saving it. Let's look at it. And it broke. Let's see if there's anything in the log. Nothing. Okay, so we feed it 4. Attribute vec4. Coordinates 4. Get rid of this altogether. Oh, we got extra comma. Maybe that did it. Hopefully that did it. No, that didn't do it. Well, we have a 4 here. It's supposed to be 3. Where did we feed widths? Widths length. Widths. Vec4. Attribute vec4. So when you make a mistake, it can be hard to find it. There's no feedback, nothing. Just don't see the result. Let's change it back to 3 again. Leave it 4 here and just send it 3. Oh no. I guess it fills it in. Let's make that a var dim equals 3. Oh. var dim is 3. Triangle's back. Let's try this. 3. I'm not sure why it's not working. No, it's not gonna work for sure. Change that to 4, so it fills it in. Let's try again. Four. Let's go. Let's go. Dim 3. Dim now 4. And it's not gonna work for some reason. Alright, well, just forget it for now. Maybe we'll find out later what the issue is here. But we do have an issue. Can't supply the perspective? But we don't even know what perspective is right now. So there's no reason to complain about it. Okay, so you're gonna give three-dimensional points. You have an array where each 3 numbers is 1 point. But then here you're gonna put vec4, and let's see if we X out the translation. If that breaks it. Right now it works. There it is. Now I'm gonna change it and see if it's a 0 from the start. So now instead of putting, we're gonna feed it a vec3 and see if that got converted to vec4 already. Alright, so that works too. So this coordinates, even though it's being fed 3 points, since we did vec4, for some reason, magically it's working. It doesn't make sense as it should work based on what my understanding is of the code, but it does work. gets filled with the vec4 for some reason, and it knows that. It doesn't make the mistake of because on the buffer they're size 3. It's mapping fine. Okay, well that's done. Next, translation. That's it. Translation. Next after this comes more complicated math. It's not really complicated. You don't have to even learn it. You just have to make sure you copy it properly into code once you make the code. But now we're gonna have some more aggressive, some more. See, now we gotta have more point. No, where's the array? Oh yeah, these are the straight. I showed this one. The lines, triangle, strip versus triangle loop versus line strip and line loop and lines. That's what they look like. Going a quad, we did colors. After we went up to translation. Next after translation, I'm scaling. Now we're gonna use matrices.